Hi, and welcome back. Since I started my journey through medicine, I have been increasingly humbled by just how much information there is and remains to be both learned and discovered. Throughout my medical career, be it my education in high school, college, medical school, even in residency, I've gained an increasingly intimate understanding of how my body, how the human body actually works. And every day I show up to the hospital, I realize how much further we have to go. I know that sounds like a pessimistic view, but since I started in medicine, I also started collecting old medical textbooks. Initially, only because I thought they looked cool. Which, let's be honest, they do. But as my clinical acumen began to develop, I decided it might be nice to thumb through some of these books. And looking back decades and even centuries ago and comparing that to everything that we know today gives me a giant sense of wonder and hope as to what it is we might actually come up with over the next few decades or centuries. And I wanted to take you through one of those experiences with me, specifically with the first old medical book I was ever given as a gift. And if you are someone who works in medicine, I anticipate you will recognize the name at the top of this book. This is Lippincott's Physiology, the second book. This was a 3-book series. I've only ever found the second one. What's cool about this book is not just that this one is in terrific shape, but that this book is more than 100 years old. In fact, it was published in 1909. It's pretty cool. So, what I wanted to read to you tonight was one of my favorite sections of this book. This is the circulation of blood. Why the blood must circulate. The blood receives all the food, and every cell of the body needs food. But the cells are nearly all fixed in one place and cannot go after their food, so it must be brought to them. The muscles in the arm, for example, would soon become weak and helpless if fresh food were not consistently brought to them in the stream of blood. The cells in the brain would at once cease their action if the supply of blood were shut off. We would not be able to think. If the brain cells did not get their constant supply of blood. When a cell uses its food, it always produces some waste that must be carried away. The circulating blood does this also. Circulation, then, does two important things for the body. One, it carries food to the cells, and two, it carries waste matter away from them. How the stream of blood gets a fresh supply of food. The stream of blood is forced by the heart to go around and around through every part of the body. At one place in its circuit, it comes very close to the food in the intestines. Here is where the blood takes up a fresh supply of food. The blood may be compared to a delivery wagon, which makes a circuit through a city and delivers groceries from house to house. Each time the wagon completes a circuit, it is again loaded at the grocery and proceeds with its work of distribution. The blood flows slowly through the fine tubes in the villi of the intestines at all times, and some food is taken into it at all times, but most rapidly just after the digestion of a hearty meal. All the food, except the fats, as soon as it gets into the current of blood, is carried straight to the liver. The liver. The liver is one of the organs of digestion because it makes the bile, which is needed in digestion. But it has other work to do, which is more important than making bile. The liver is a gland. It is the largest gland in the body. It is placed on the right side of the body, just below the diaphragm, and weighs from 3 to 4 pounds. It is made up of a great number of liver cells, and between the cells are thousands of fine tubes, which carry blood through the liver, close to the cells. These cells make important changes in the blood while it flows by them. The use of the liver. All the blood that circulates through the walls of the stomach and intestines, where the new food is taken up, is next carried to the liver. The liquid food is not ready to go to the heart until it is first acted on by the liver. The sugar that was eaten and the starch that was turned into sugar are stored up in the liver. In that way, this large gland acts as a storehouse for the body and deals out food little by little as we need it. If it were not for this work of the liver, we would have to eat a little nearly all the time, just as we now have to breathe all the time, because we have no storehouse for air. The liver also takes out of the blood many things which would harm or poison the cells if allowed to circulate through the body. In that way, the liver is always on guard and always trying to keep the blood pure. The liver, then, does three things. 1. It makes bile for use in digestion. 2. It acts as a storehouse for food. 3. It purifies the blood. After food passed through the liver, it was carried by a large vein up to the heart. The thoracic duct. Nearly all the food that was taken up from the intestines was carried by blood vessels straight to the liver. But most of the fat did not go that way. Each villus of the intestines contains, besides the fine blood vessels, another tube called a lacteal. These tubes gather up the fat and carry it to the thoracic duct. The thoracic duct is a tube which runs along the spinal column and joins a large vein in the left shoulder. In this way, the fats are also carried to the heart. The course of the blood. The blood is forced by the heart to go out through the tubes that run to every part of the body and then return to the heart again. These tubes are closed so that the blood cannot get out, except as some parts of it may soak through the cells. The organs that make the blood circulate and carry through the body are the heart, arteries, capillaries, and veins. The heart, my favorite organ. The heart is the chief organ of circulation. The blood would soon cease to flow if the heart should stop beating. The heart is just above the diaphragm, at about the center of the chest. It is a hollow bundle of muscle in the shape of a pear. Its large end towards the right shoulder, and the small end points forward and to the left. The heart is enclosed in a bag called the pericardium. This bag is lined with a very smooth membrane, which is always moist. For when the heart beats, there is almost no friction between it and the pericardium. The heart is a double organ. There are two separate hearts joined together as one. They are called the right heart and the left heart. The right heart receives all the blood as it returns from its journey through the body and sends it to the lungs. The heart receives the blood when it comes back from the lungs and sends it through all parts of the body. The left heart has the much harder work to do, and so it is stronger. The cavities of the heart. Each side of the heart contains two cavities. The upper one are called atria, and the lower ones are called the ventricles. So there is a right atrium, and a right ventricle, and a left atrium, and a left ventricle. Each atrium is separated from its ventricle by a valve. The valves of the heart. The valves in the heart are arranged just so. The blood flows into the heart, and then the strong, muscular walls squeeze upon it and force it out. But this would be of no use if the blood could flow back through the same tubes by which it entered. So each side of the heart is provided with 2 valves. The right has 2, and the left has 2. The blood enters into the right atrium and flows through the tricuspid valve. This valve opens only towards the right ventricle. When the right ventricle contracts, the tricuspid valve is pushed shut, and blood can only get out through the pulmonic valve. In that way, the blood is pushed through the pulmonary arteries, which carry the blood onto the lungs. When the blood returns from the lungs, it enters the left atrium and passes on through the mitral valve into the left ventricle. When the left ventricle squeezes upon the blood, the mitral valve is pushed shut and the aortic valve opens. Thus, through the aortic valve, blood is carried all through the body. Arteries. Arteries are tubes which carry the blood that is sent out from the heart. They are elastic, like a rubber tube, and always stand open, whether there is any blood in them or not. One large artery leads out from each ventricle, and one from the right ventricle is called the pulmonary artery because it carries the blood to the lungs. One from the left ventricle is called the aorta. It is the large tube that curves up over the heart, sends off its branches to the head, arms, legs, trunk, and in fact to every part of the body. These branches divide into finer and finer branches, until at last the artery is so small it cannot be seen without a microscope. Capillaries. The capillaries are tubes, still finer than the finest arteries. When the blood reaches the end of an artery, it passes on to the capillaries. All arteries carry blood into capillaries, and all capillaries pass the blood into veins. It is while the blood is slowly moving through the capillaries that the food oozes through the cells. All parts of the body are filled with capillaries. It is not possible to push a fine needle through the skin without piercing one or more of these fine tubed blood vessels and letting out some blood. They are very small, varying in length to very small fractions of an inch. The whole use of the heart and the arteries is to keep the capillaries filled with blood. Veins. Blood moves through capillaries at the rate of about 1 inch in a minute. This gives time for the liquid food in the blood to get into the cells, and for waste in the cells to get into the blood. The blood is then collected by a vein. Veins are at first very small, but a great number of them unite and form larger and larger ones, just as many small streams of water often unite to form a large river. All veins are at work, carrying blood back to the heart after it has passed through capillaries. Veins do not have thick walls like arteries, but they have many valves, while arteries have none. These valves are only small pockets on the inside of the vein. When the blood flows towards the heart, the valves do not hinder it, for they are pushed up against the side of the vein. But if the blood starts to flow in the other direction, the pockets fill up and close the vein. Blood. Blood is a liquid, which the heart forces around and around through the arteries, capillaries, and veins. The blood has 3 important duties to perform. 1. To take up the food after it is digested and distribute it to the cells in all parts of the body. 2. To take up oxygen when we breathe into the lungs and carry it to the cells. And 3. To gather up waste matter and carry it to the lungs, kidneys, or skin, where it is cast out. The blood is made up of a thin liquid, in which a great number of corpuscles are always floating. These corpuscles are of 2 kinds, red and white. Red corpuscles. Fresh blood is always a bright red, but the color is due to the red corpuscles. These little bodies are so numerous that they make the blood look red. The red corpuscles are very small discs of solid matter, and they have the shape of a donut. It would take over 10,000 of them, placed one upon the other, to make a pile 1 inch high. These little discs are a very important part of the blood. They are the oxygen carriers. Every time they pass through the lungs, each one takes up a small load of oxygen and carries it out to the capillaries, where the oxygen is given to the cells. While the corpuscle is loaded with oxygen, it is a bright red color. But after it has passed through the capillaries and lost the oxygen, it is no longer red, but purple in color. So the blood in the arteries is red, and in the veins purple. The only exception to this is that the artery from the right ventricle to the lungs carries purple blood, while the vein from the lungs to the left atrium carries bright red blood. White corpuscles. White corpuscles are found floating in the blood with the red ones. They are larger than the red, but there are not nearly so many of them. They are single cells and have a nucleus. Their movements and manner of life are very much like that of the amoeba. A white corpuscle may rest and float along in the blood, or it may slowly move itself about. When it wishes, it can stretch itself into a fine thread and can go right through the wall of a blood vessel to other parts of the body. The use of the white corpuscle. The white corpuscles are of great service to the body. They are all the same. They are all the time in search of any small particles that would do the body harm, and, if they can, they will permit nothing to be in the blood or muscles or other parts of the body unless it rightly belongs there. When one cuts his finger, it may become very sore. This is because there are always many little live germs in the air and on the skin, which can get into the cut. They find good food there, and will multiply and live there unless they are destroyed. When this happens, the white corpuscles will gather around them in such numbers that the small wound will become swollen and inflamed. They attack the little enemies that do not belong in the body and try to destroy them. In most cases, they will succeed and the enemy will be driven out. But many of the white corpuscles will lose their lives in the conflict, and the white matter, called pus, which appears in the sore, is composed of their dead bodies. So we may think of the white corpuscles as kind of a standing army within the body. When the health is good, the standing army will be strong and can easily repel any enemies that try to get in. When the health is bad and the body weak, one can more easily catch a disease because the standing army is weak. Blood clot. The body has many ways of keeping itself well, fighting off disease and healing up wounds. The doctor could do very little for the body if it did not do a great deal for itself. A slight cut would soon let out all the blood, and life would cease if there were no way to stop it. But nature has a way of checking its flow by forming a blood clot in the wound. While the blood vessels and the blood is thin, while in the blood vessels, the blood is thin, but as soon as it is outside, it becomes quite thick. It would be very difficult to stop the bleeding at the nose if a blood clot did not stop the end of the fine artery from which the blood comes into the nose. When a large artery is cut, the blood comes out so fast that a clot cannot stop it, and the surgeon must be called to tie the end of the artery. The pulse. The pulse beats as often as the heart does. It can be felt at any place where an artery of good size runs close to the surface. It can be most easily felt and counted at the wrist, just a little above the thumb. The arteries are full of blood all the time, and every time the left ventricle contracts, it forces more blood into the aorta. This causes a pulse, or wave, to run out through all the branches of the aorta. This is what we can feel at the wrist. Change in the size of arteries. The walls of the arteries are provided with muscles which run around the arteries. When these contract, they make the tube smaller, and less blood can get through. When they relax, the tube gets larger, and more blood flows. This is regulated by nerves, which are connected to these muscles. When any part of the body needs more blood, the arteries that carry blood to that point will open and let more flow. When one goes out on a cold day, the small arteries under the skin will contract and keep the blood in near the center of the body. This keeps heat from escaping too fast. Different paths of the blood in its circuit. When blood is forced out by the heart through the aorta, it goes to all the capillaries in the body. But the part that goes to the stomach and intestines, where fresh blood is taken up, is gathered up by a large vein called the portal vein and carried to the liver. In the liver, this blood is changed and purified, and has already been explained, and carried up by a large vein into the heart. Another branch from the aorta carries blood to the kidneys. There, the poisonous urea and a large amount of water are taken out. This blood, too, is then emptied into the large vein that leads up to the heart. The large artery from the right ventricle carries the blood to the lungs, where water and carbon dioxide are taken out of it, and oxygen is taken up by the red corpuscles. While this is going on, other portions of blood are out in the muscles, the bones, the skin, and every part of the body, feeding the cells. So the blood is flowing through many circuits at the same time. The beating of the heart. If the hand be placed on the left side, at a point between the 5th and 6th ribs, the beating of the heart may be distinctly felt. The two sides of the heart work together. Both atria contract at the same time and fill the ventricles. Then the two ventricles contract, the right one sending its blood to the lungs, and the left forcing blood into the aorta. The ventricles are strong, and when they contract, they cause a movement, which has caused the heartbeat. If the ear be pressed against the chest, right over the heart, the closing of the heart valves can be heard. Their sounds are nearly like lub-dub. Work and the rest of the heart. The heart must work hard, day and night, from the beginning to the end of one's life. It beats about 70 times every minute, sometimes more, and sometimes less. The heart does not seem to rest at all, but it does rest nearly half the time, though its periods of rest are only short time between heartbeats. The heart needs a great deal of food to keep it strong for the hard work it has to do. It does not get food from the blood inside of it, but the first artery that branches off from the aorta carries fresh blood to the muscles of the heart. Good blood. Good blood and good circulation are almost sure to keep the body in good health. The body may continue to live when the blood is poor, but it cannot be strong and healthy. Several things are needed to make good blood. Sufficient food of the proper kind must be digested every day and taken into the current of blood. blood can only get what we eat and digest for it. If we eat poor food, the blood will feed into the cells and, of course, the whole body will have to suffer. Blood is not good unless it contains plenty of oxygen. The oxygen we breathe is just as important as the food we eat. Some waste matter is constantly being produced by the actions of the muscles and nerves, and this goes into the current of blood. The blood would soon become very impure if it were not for the work of the liver, lungs, kidneys, and other organs that take these impurities out and purify the blood. The nerves must be able to control the size of the arteries so that the right amount of blood will be carried to the place where it is most needed. How exercise helps circulation. We have explained that the blood will be sent out to different parts of the body in proportion to their needs. If the right arm is made to work harder than the left one, more blood will flow to it. The more work the cells do, the faster they use up their food, and so they need more blood. Now, if one takes some active exercise, in which many muscles are made to do work, more blood will be needed, and many parts of the body. The arteries will become larger, and the heart will beat faster. Every organ of the body is aroused to activity. The food is rapidly used up, and a sensation of hunger begins. Hunger is simply the call for more food. Alcohol and the heart. When alcohol is taken into the body, it makes the heart beat more rapidly. In some cases of sickness, when the heart gets very weak and is unable to keep the blood flowing, doctors give some brandy or whiskey to stimulate its action. This makes people think that alcohol is good for the heart, but it's found that after the excitement caused by the alcohol has passed away, the heart is weaker than before. This is the reason some good doctors will not give alcohol for any kinds of sickness. After one has used beer, whiskey, or other alcoholic drinks for a long time, the heart often becomes weak and unable to keep up a good circulation. This is because some of the muscles in the walls of the heart change to fat. Fat is not able to do any work, and so the heart loses its ability to force blood through its circuit in the body. Alcohol and arteries. The size of the arteries is controlled by the nerves. If the nerves do not act, the arteries will stand wide open. Some parts of the body will then get too much blood, and other parts not enough. A large dose of alcohol will paralyze the nerves for a time. Then there is no way to regulate the flow of blood. This can be seen in the red face and nose and the bloodshot eyes of the drunkard. When one is exposed to cold weather, the blood vessels keep the skin cold and keep the blood within the body. But alcohol will take away this power of the nerves, and blood can flow close to the skin. This seems at first to make the body warmer, but heat is rapidly getting away, and after a time, the whole body will be colder than it would have been without alcohol. Alcohol and blood. We have already explained what is needed to make good blood. Unless digestion is good, the blood will not be good, and we have seen how alcohol interferes with digestion. Unless the liver, lungs, and kidneys keep the blood pure, it will carry harmful substances to the blood. Unless the liver, lungs, and kidneys keep the blood pure, it will carry harmful substances to the cells. Alcohol hinders the work of these organs and gives them more work to do. Tobacco and circulation. It is claimed by good physicians that much of the heart trouble and heart failure is caused by the use of tobacco. The nicotine in tobacco makes the heart palpitate and beat in an irregular manner. This effort is most plainly seen in young people who, if they use tobacco at all, are almost sure to use it in excess. The effect on the blood and the organs of circulation soon shows in the bad health of the whole body. Now, some of this information is very rudimentary to our understanding of the human body. Much of it still true. What tickled me most about this was the red and white corpuscles and the description of an alcohol-induced cardiomyopathy that 100 years later we have much more information. The seemingly suggestive correlation between excess alcohol and tobacco and poor health has been what seems like infinitely more specified over the course of the past 100 years. And indeed, we understand so much more about how the nervous system controls arteries and controls blood pressure. And we know that the kidneys also control blood pressure, not just the nerves and the brain and the sympathetic and parasympathetic nervous systems. There is just so much more about the body that we understand today than we did when this book was published 111 years ago. And that makes me excited for the next 100 years of medical advancement, just to see how healthy and smart and intimately related to our own inner workings we can actually become. But for now, I'm tired, and I hope you are too.